This is a 128x64 OLED monochrome display. It is compatible with Arduino so that you can control with it in order to display text, graphics or even images such as bitmaps. The biggest advantage of this display is its OLED technology and higher resolution. So, in this video we are going to learn how these displays work, how to control them, some tiny little projects which you may find useful. So, let's get started. First, we are going to take a closer look at the OLED display. My OLED display is a 128x64 monochrome SSD 1306 driven I2C 6-pin Arduino compatible display. Don't worry if you have a SPI interface display. You can make it I2C by shifting the resistors which is backside on the display. It also has a reference where the resistors need to be placed. In this video we will be using I2C display, because it needs only 2 pins to communicate with Arduino. But don't worry, you can change to I2C by shifting the resistors or connect your 6-pin OLED SPI display as shown in the schematic. There exists 2 types of SPI. The hardware SPI and the software SPI. You also don't worry for the types because I also made Sprat codes for you guys. Next, we can talk about the driver of the display. It is SSD 1306 monochrome display driver, which can control 7 segments which contain total of 8192 pixels. This driver has about 1 kilobyte of RAM on it. To communicate it over I2C, we need to connect the SCL or otherwise serial clock pin of the display to the analog pin A5 of the Arduino and the SCL pin of the display to the analog pin A4 of the Arduino. If you have a reset pin on the display, pin 4 of the Arduino. You can also change the reset pin, but you cannot change the SCL and SDA pins because Arduino Nano or Uno has only one I2C port. VCC and GND can be connected to VCC and NU respectively. If your OLED display have DC pin like this, you can connect it to 3.3 volts. First, you need to download the recommend libraries. You need to download the Adafruit GFX for graphics support and the Adafruit SSD 1306 library for controlling the display. After installing it, open an example sketch from the Adafruit SSD 1306 library. I choose I2C 128x64 because I'm using an I2C OLED display. Point 1 stone you need to do here is you want to choose the correct I2C address of the OLED display in order to produce the correct frequency signal. To know the correct I2C address of the OLED, you want to upload the given I2C scanner sketch to your Arduino connected with the OLED display in order to find the correct I2C address. Link to the scanner is in the description below. The I2C address will be displayed in the serial monitor. Copy the code and paste it in the Adafruit sketch. It is usually 0x3C or 0x3D. Now upload your code. You should get the Adafruit splash screen and some animations. Using this sketch, you can see whether the display is working properly. Let's see what is important. First, you need to define the reset pin of the OLED display in case if you have it. Next is the void setup. Here you need to begin the communication by writing display, begin name blah, 0x3D. The name blah is the code which sets the Arduino to generate 3.3 volts internally. This is because a lot of OLED displays work at 3.3 volts. The thing is that net to the comma is the I2C address. The next important thing we need to write is the display, clear display. If you didn't write it, Adafruit's default splash screen will be shown. And that's how you do a simple programming with Arduino to control OLED displays. The next part will focus on making simple projects on them. Until then, like this video, share with your friends, and don't forget to hit the subscribe button.